For 6 months, astronaut Ron Guerin lived and worked on the International Space Station, and he saw our world in a way few people can imagine.
The Caribbean is like a glowing jewel. The Himalayas, the Middle East. There's many, many really interesting, beautiful places from space.
The space station gives us the ability to explore our home planet in a way we never could. But that God's eye view is getting dangerous.
We have a somewhat risky environment that we've created because we are surrounded, our planet is surrounded by this cloud of space debris.
3, 2, 1, 0.
For almost 60 years, we've launched rockets and spacecraft into Earth's orbit. But now, thousands of objects, from tiny screws and bolts to dead satellites, encircle the Earth, transforming the space above us into a junkyard.
It seems kind of comical, the idea that someday the Earth might actually be surrounded by some ring of space garbage, kind of like a less nice version of Saturn, but it's a real possibility.
Now, the International Space Station is in the crosshairs.
The International Space Station has already been hit by little bits of debris on a number of occasions, and there are no guarantees that other substantial things might not hit it again in the future.
It's the job of the military to monitor the thousands of pieces of debris orbiting the Earth. The men and women at Vandenberg Air Force Base in California are keeping their eyes on the skies 24 hours a day.
So currently we monitor and track approximately 23,000 objects in space. Among those is about 1,300 active payloads or satellites, and the rest being space debris from prior launches or prior collisions. Everyone on Earth should care about what's going on with space objects and space debris because we're so reliant nowadays upon technology that if something were to happen to a satellite, it's going to severely degrade our ability to do certain things, whether it be ATM withdrawals, GPS, or anything.
It's critical that we track space debris because it poses a risk to all the active payloads, including the International Space Station. Some of this debris we track up to 10 centimeters.
Even a piece of debris the size of a small screw could destroy the space station.
If you can think of a 2-centimeter ball bearing up in space, it's traveling at 17,000 miles per hour. That force is equivalent to a Jeep Wrangler traveling at 70 miles per hour. So as the object size increases, the impact and the force behind that collision could be astronomically larger.
In June 2011, Ron Guerin found himself facing that danger firsthand.
I was maybe 4 months or so into the mission, and we got a call from Mission Control that a piece of space debris was going to pass a lot closer than people wanted. If we know about it soon enough, we will change the orbit of the space station. We can boost it up higher or lower and change it so that we avoid that object. But for whatever reason, this one caught us by surprise, and we did not have enough time for us to be able to move the orbit of the space station.
With the astronauts staring down the threat of a collision, they're faced with only one choice: abandon ship.
The International Space Station has several different ways of trying to deal with potential collisions, but the last-ditch defense are the 2 Soyuz space capsules, because those are basically lifeboats.
Ron and the crew race to the Soyuz capsules. Now, the only thing they can do is brace for impact.
And then it was just a waiting game after that. But we didn't know if it was going to hit it or not.
In June 2011, the crew of the International Space Station learns their lives are in imminent danger. Space debris is heading towards them.
NBC's Jeff Rawson watching all of this. Jeff, good morning to you.
Space junk was on a collision course with the International Space Station. Spotted so late, there was no time to move out of the way. Instead, the 6 astronauts got the order from Mission Control.
The probabilities are still in the red threshold. and we are planning to have you shelter in place.
If all else fails, the astronauts on board the space station can climb into those Soyuz space capsules and wait to see whether a collision actually takes place. If it does, they can in a few seconds detach from whatever's left of the space station and then immediately try to return to Earth.
Mission Control orders the astronauts to the Soyuz lifeboats. It's only the second time a crew has been told to potentially abandon ship.
Once we got all the hatches closed and when we were all buttoned up in our Soyuz spacecraft, there really was nothing to do but wait. We discussed, okay, if things get really bad, this is what we're gonna do. We're gonna undock. We're gonna, we started to talk about that. And then it was just a waiting game after that. But we didn't know if it was gonna hit it or not.
Finally, after 15 minutes, word arrives from Mission Control.
When the object passed the space station, we got a call from Mission Control that, it was all clear. And it turned out that this object passed within a football field of the space station, and relative velocity was 8 miles per second. So it's a fairly large object, traveling that fast, it probably would have destroyed the space station had it hit.
But with thousands of objects orbiting the planet, the next time, they might not be so lucky.
There is evidence of hits on the space station and a little piece the size of a grain of sand that really make a bad day. It's something that should be a major concern if we're going to continue to use the environment of space for the things that we want to use it for.
Exploring Earth in the 21st century means capturing it from above. But space debris is not the only threat to this unique perspective.
The sun seems to be always there and unchanging. It's just this bright ball of light in the sky. But in fact, it's changing all the time. And that affects us here on Earth because we are bombarded by radiation from the sun, both in the form of light and subatomic particles.
The Earth's atmosphere is a protective shield for anyone on the ground. But in space, there's no escape from the power of the sun.
Solar flares and other kinds of violent eruptions from the sun are very, very dangerous for anybody who's in space. The amount of radiation that suddenly is pouring off of the sun at that point jumps way up. And we can try to create certain kinds of very shielded areas that the astronauts can hide in, but even those can only offer a very inadequate protection against the level of radiation that the sun can suddenly release at those times.
An extremely powerful solar storm could send the crew looking for cover.
What we would do is we'd find a place on the space station that offers the most protection. Water turns out to be a fairly good insulator of radiation. We do have bags of water on the space station, and we'd probably huddle some bags of water into a location and get behind that as best we could.
But in spite of that danger, the same powerful burst of energy also gives the astronauts on the space station front row seats to the greatest light show imaginable.
The auroras are just incredible. And there were times on my mission where we flew so close to the auroras that you could reach out and touch them. I mean, they were going right by the windows. It was absolutely incredible. The pictures really don't do them justice. They really do dance.
But what you're seeing, really, is the after effect of a tremendously energetic and dangerous solar storm. These subatomic particles screaming across the solar system at just under the speed of light are getting swept up by the Earth's magnetic field and funneled down into our atmosphere. It's humbling and amazing.
From discoveries at the edge of the solar system and beyond, to mysterious asteroids hurtling through the cosmos, and the search for life in our own backyard, images have transformed our understanding of the universe.
Everyone knows the cliche, a picture is worth 1,000 words. But to me, being a scientist, you have to find a way to turn cold numbers, just data, into something that emotionally resonates with people.
We are trained to be very, very logical. But all of us really are just like everybody else, and we're emotional, and, you know, we get excited about a beautiful scene and can, you know, just spend hours looking at something and imagining what it would be like if we were there.
And these images are the result of cutting-edge missions, driven by the explorers willing to put everything on the line to capture space's deepest secrets.
These days, I think we've seen that there's a whole new team of heroes. These teams of scientists and engineers, they're the ones inventing these craft. They're the ones devising these missions. They're the ones making sure they come off without a hitch. They're the real heroes now.
What they'd seen with their telescopes was an exploding star. But the explosion was far larger than anyone had ever witnessed before. And in the heart of that cataclysmic explosion, the researchers realized that something astonishing and terrifying had happened. As the massive star died, a monster had been born.
What we'd witnessed was the birth of a black hole.
What Boyle's team had seen was the death of a star so heavy that when it exploded, its entire mass collapsed inwards instead of blasting outwards into space. This star is absolutely huge. It's 100 times bigger than our sun, thousands of times brighter. But it doesn't just explode. As its surface layers blast outwards, its core is smashed inwards. The center of the star collapses in on itself. Billions upon billions of tons of star stuff crushed smaller and smaller until the whole star is squeezed to a single microscopic point. And from the remains of the dying star, a black hole is born.
In our galaxy, a massive star explodes and creates a new black hole every 1,000 years. Which may not sound like a lot, until you remember that the galaxy has been here a very long time. Speeding up its history, you can see that stars have been going off like firecrackers. And when a black hole is born, it never dies. Every black hole that was ever created is still out there, so there should be around 10 million of them, somewhere. The question is, where?
Until recently, black holes remained unseen in the depths of space. But something as deadly as a black hole can't remain hidden forever. Like most predators, they leave a trail of destruction. And scientists are now beginning to recognize these telltale signs. One black hole hunter is John 11.
Even though black holes are dark and invisible, it doesn't mean they have no effects. They're extremely strong vortices, and they pull matter in these swirling winds around them, a lot like a tornado. And just like a tornado, you might not see it until the debris begins to get sucked up, like this tornado is now pulling the gases in it. And so suddenly you can see the presence of this vortex, this strong swirling wind.
It isn't the wind of a tornado you see, it's the havoc it creates. And that's how we detect black holes too, by the damage they do.
Even though tornadoes are incredibly powerful, you don't see them until they suck stuff into them, until you see them pulling up cattle and houses and cars and gas and smoke and clouds. And it's the same thing with black holes. So you don't see them until they pull in the matter around them.
This is what astronomers look for. Not the black hole itself, but stars caught in the black hole's incredible gravitational pull. This one is tearing apart a star that drifted too close. A feeding black hole is anything but black. The whole star is wrenched out of shape as the monster tugs at it. Gas from the star whirls around the hole. It forms a superhot disk of star debris 100,000 kilometers across. It's a deadly embrace that will last millions of years. And what the black hole can't swallow, it belches out. Huge jets of uneaten star are spat out into space.
Some of the most spectacular kinds of black holes we've seen are so powerful, they're drawing in so much material and spinning so rapidly that they create these huge jets, these powerful funnels of material. That are thin but incredibly, incredibly long, incredibly vast. And the jets themselves can cross as much as an entire galaxy. They're absolutely huge.
The damage a black hole inflicts on a star can be seen clear across the universe. Once astronomers knew what to look for, they began to hunt for feeding black holes. Using powerful space telescopes, we've tracked down more and more of them. And these are the actual images. Black holes tearing apart everything they meet. Most of them are remote. They're in distant corners of the universe. and we've only found them because they're feeding. But what about the black holes that aren't feeding? Where are the millions of black holes that should be wandering through our galaxy? They remain hidden against the dark background of space.
Luckily, there is a way of tracking even the blackest of black holes. And this is what gives them away. Light. A black hole's gravity is enormously powerful. It affects everything around it. It can even bend light. So when a black hole passes in front of a distant star, the light from that star is distorted. And the black hole gives itself away.
Finding a star at the precise moment it's distorted by a black hole is a daunting task. But that didn't stop one very, very patient astronomer trying to see the invisible. Tim Axelrod has dedicated many years of his life to the pursuit of the universe's hidden objects.
For the last 8 years, we've been looking at the same patch of sky every night, monitoring the brightness of 20 million stars. The reason that we're doing this is we're looking for microlensing events. These events are extremely rare, but they occur when a massive object passes across our line of sight to a distant star.
Axelrod set about his search for what he calls gravitational microlensing. When a star's light is distorted by a massive object like a black hole. But the odds were stacked against him. At best, his chance of finding the right star was 1 in a million.
That factor just seemed impossibly large to people, so most people thought that we would fail pretty dismally.
Undaunted by the enormity of the task and the skepticism of his colleagues, Axelrod set about looking for that one telltale pinprick of light amongst 20 million stars, every night for 8 entire years. Then one night, he hit the jackpot.
Here we have a view of the Large Magellanic Cloud. The blue square shows the field of view of our telescope. So now we've zoomed in a bit. The star which we're interested in is a pretty inconspicuous fellow right in the center of the crosshair. Now we zoom in yet again. This is picking the needle out of the haystack. And what we saw when we looked at it over a period of time was this. We were naturally ecstatic. Everyone that saw it agreed immediately that this was gravitational microlensing, so we were just over the moon.
Far out in space, he had seen the impossible. A massively heavy object like a black hole sliding silently in front of a distant star. Next, Axelrod turned to our own galaxy. What he saw was disturbing. Evidence not of 1 or 2 black holes, but hundreds. But is that anything for us here on Earth to worry about? Could our own fragile planet ever encounter one of these invisible